Okay. So this flight controller connection already you are aware of it. Okay, how to connect that flight controller. Okay. Now what I have done is I directly connected the flight controller. I ensured that it is in a fixed wing firmware. Okay, because in fixed wing we can able to use the airspeed sensor. Other quadcopter there is no use of airspeed sensor. Okay, so I have ensured it is in fixed wing. Okay, so later I should know the connections. Okay, so what I have done is randomly I have searched Pixhawk airspeed sensor connection. Okay, so first link is R2 Pilot. So we have installed R2 Pilot firmware. So we should go inside the R2 Pilot site. Just go inside. There, instructions were there. Okay, just scroll down. Here it is mentioned autopilot airspeed connection. Okay, so connect the airspeed sensor module to I2C port. Okay, are you getting? So you can find I2C port here. Okay, now I will just disconnect, then I will show it. Okay, so in this flight controller you can see I2C. Okay, now in that I2C port I have connected this cable. Okay, so you can see airspeed sensor, that connection should go to the I2C port. Some flight control, some airspeed sensor, different sensor, you are supposed to connect it in CAN. Okay, if it is not working in I2C, you are supposed to connect it in CAN. Okay, now usually it will connect with I2C. Okay, in I2C you can able to use I2C splitter, kind of USB splitter you will be using, right? One port to three or four ports. Likewise I2C also you can split it. Why it is required means, if you are going to add 2 to 3 sensors, then you need I2C. Only one port will be here, but you can extend it. Okay, now we are going to use only one sensor. I have directly connected it. Okay, once it is connected, it will show that normally it's default to 1. Okay, that I will show there. Okay, now I'll open mission planner. Okay, I can connect it. After connecting it, just go to the configuration. Okay, so under that configuration, full parameter list will be there. Under that parameter list, ARSPD, which is related to airspeed sensor. Okay, if you are clicking it, all the parameters which is under that will be visible here. Okay, now airspeed sensor type, it is I2C. Okay, if you are going to connect it in drone CAN, that you have to change it. Are you getting? uh, it will be in a record that you check it. Airspeed type and airspeed use, these two we are going to use it. Okay, so type is I2C, so we have connected through I2C, so it is default 1. Okay, airspeed use, this might be in 0 some cases. Okay, so this you have to make it in 1. Okay, once it is done, you have to write the parameter. If you are writing, then only it will go to the flight controller. Otherwise you will do the change, then if you are seeing, it will not reflect. Okay, so how to write means, make the changes and just click write, then click yes, so it will be shown the message, successful message, parameter has been written. Okay, then it is connected, go to the data. Okay, here you can able to see the airspeed. Okay, here, are you getting? Fine, that is because we cannot hold it, we cannot blow it. It will get choked. So likewise, keep it, blow it, so you will get the readings here. Okay. Are you getting? Okay. In your wind tunnel, you are doing the wind tunnel calibration. YouTube manometer you will do, right. So similarly, we can able to perform. So one time we have calibrated our wind tunnel with this equipment. Okay, so whether it is coming uniform flow or not, this we have, at the time we have bigger tube, so we have connected into the traverse mechanism, the 2D. So we have checked the velocity in all several points. Okay, in the same plane perpendicular to that wind tunnel section. Okay, likewise you can do it. And why this sensor is important means, when you are going to launch the plane in hand launch, okay, at the time the propeller will not be spinning, the time we can able to adjust it. Okay, I'll just show it here. see here, automatic takeoff, plane documentation. Here hand launch. Okay, so under that plane automatic takeoff, hand launch. Okay, here there will be a delay timing. Okay, throttle delay, some timing will be there. Okay, are you getting? Throttle delay. Okay, at that cases there will be a minimum speed. If it is attaining that speed, then only the propeller will start spinning. Okay, how it will get to know it is attained that speed? We should connected with the airspeed sensor. So airspeed sensor input it will take. If it is reaches 10 meter per second or 15 meter per second, then the propeller will be started spinning, it will blow. So usually we will be keeping it 10 meter per second or 5 meters per second. It is depends on the cases. Some drone requires cruise speed of 7 meters per second, then we will use 10 meter. If it is cruise speed is 3 meter per second, means 5 meter per second. So like this. Why we are giving excess velocity means then only it can able to generate that sufficient lift. Okay, it will run. So this is the way we will be connecting the sensor. Okay, likewise different sensor will be mentioned in different ports. Okay, now I said I2C and CAN, right? Okay, so similarly based on the sensor you have to connect it. Usually the sensors will come into the I2C or CAN port. It will not come under any other port because other ports are related to telemetry, power and GPS. Okay, only these two ports are related to the sensors. Okay, this sensor I2C and CAN means it will give certain readings to the flight controller. Okay, servo motor will not give any reading, so it will go to the other outputs. Are you getting? Outputs are different, sensors are different, inputs are different. GPS is input. Here airspeed sensor means it requires some communication. Okay, if it is a two-way communication, we can able to use I2C or CAN, but here it is not a two-way. It will just get the reading. It is just a reading sensor. Okay, are you getting? So now I will give it. You can just check it in your mission planner. Okay, if you are having any doubt, we can ask. Okay, fine. Now you can take your seat.